In the previous video, we have discussed how to construct the computational graph for the deep learning framework. And in this video, we will discuss how to use some syntax sugar to make the programming more intuitive. In the early days of the deep learning framework, such as the early release of the TensorFlow 1, we need to write the formula in this way. Okay, so this is actually the mean square error, which has the formula like this. Okay, so we subtract the prediction with label and the message square so that we only care about the difference instead of the absolute value. And then we take an average of this value. So this will be a loss function to indicate the difference between the prediction and the label. And in the TensorFlow 1, we need to write the formula in this way, so that we using subtract function to subtract the prediction and the label, and then we take a square, and then we divide this number with the n here. However, this is not very intuitive. We hope that the formula can be written in this way. So the meaning will be very clear. We do the calculation between those two variables and make it square and the summation and divide by n. So this will be more intuitive than this one. Okay, but in order to write the program in this way, we need to using some syntax sugar provided by the Python language to do the job, so that we can using an expression instead of the function to do the job. Okay, so if you have a book, you can take a look at the step 11 to 24, and I will do some summary in the presentation below. Okay, but first of all, we need to rewrite the function. Since the previous implementation in the previous video, we take one argument for the call function only for the simplicity, but for the add function, we need to have a multiple input for the call function, and so here is the code to do the job. We're using the start syntax so that the inputs will become an array of arguments, so that we can add multiple arguments to the call function here, and all of them will be put in the inputs array, so that we get all the elements from the inputs. So we get all the argument here, and then make an argument as a variable. So the inputs will become an array of a variable object. Then we take the object, all the variable object from the inputs, and get the value of it as an array, which is xs here. And we send this array into the for function. So we using start here, the start syntax here. So you will actually become a list of argument. Is it to expand this array to be a list argument for the for function. So in the for function, we can use one argument, two argument, any number of argument, and then the for function should return an ys. Ys could be a single variable or a tuple with multiple return values. So if we need to check if the return value is a single variable or multiple of a tuple with multiple return values. So if it's not an tuple, we need to make it as an tuple with only one element inside it. Okay, so in here we just make every element in the tuple as an variable to be our output variable. So in this way, this new function can support multiple input and multiple output. So it will be more generic, so that we can support multiple input variable and multiple output variable. Okay, so and the next is the more important things. We need to use some syntax sugar to let us can write more intuitive expression functions. So for example, in the add functions, we implement both the forward and the backward function, and but those are the same as previously. But we can have a multiple argument for now, and actually the most important thing is the variable data underline and underscore add underscore. So this syntax is called a operator override. If you want to know more about the operator override, you can check this link. There is a more detailed explanation of the syntax. But ensure that Python interpreter will pass the Python expression and generate a syntax tree for it. If the variable is an object, we need to define a function for each operator so that the interpreter will not report the syntax error. So if an operator function is defined, the interpreter will call those functions according to the syntax tree. So for example, if we write the program in this way, x is an variable, and the variable will add to something else. So when the Python interpreter sees this line of the code, it will actually pass this line of code as a syntax tree. So it will look very similar to the computational graph we have discussed before, and so that x will send to the add operator with the 3. So x will and the 3 will be the input of the x operator, and this variable, the output of the x plus 3 and the 2 will be sent to the power operator. So actually, the syntax tree will look very similar to the line here. So we create an add operator and send s and 3 as its input, and the output of this function will be input of the power here. Okay, so it will be becoming in this way, and if since we have defined the add operator here, so actually when the interpreter see the x plus 3 here, it will call the add, which is the add here, it will call this function, and the x0 will become the x, and the x1 will become the 3. Okay, so and you may notice that the x0 must be always variable, or this method won't be called, because no, for the syntax tree, it take this one and you try to add this one with the 3, because 3 is a built-in type, so he has a built-in the add function for it, so we don't really need to define anything for it. But for the x, it's a variable object defined here. So the variable object must be defined override the add operator by this way. Okay, so the x plus 3 will actually call the function x plus 3. So for this function, we need to convert the second one into an array, because it might be 3, like in this example. So we need to first convert it into an array so that we can handle it in the following code without worry about it's a scalar or it's an array. So we always convert it into an array, and then we generate an add function object. So you will see the call function here. The construct function here. And then you will, after we have this object, we will call this object by put those two arguments, and you will actually call this function. Okay, and with an array of input, so this will become an x, and the other variable of 3. Okay, so this will be an array, and so that we need to, since in this time the second argument is not a variable, it's actually an array of the 3, number 3 in here. So the first line of code, we need to convert to make sure every variable in the arguments become a variable instead of just a NumPy object. So after this line, all the element in the inputs will become an variable. So for the implementation of the function is actually here. We will check if the object is a variable object or not. If it is an variable object, we just return it. If it's not, we convert it into a variable object. Okay. So then we check every element in the inputs and get its data, which is the value of this data variable object, and put it in the array. So this XS will be put into the argument of the forward function. We will using this to call the forward function. You may notice the star here. The star means that we will expand this array into a list argument for the function. So the forward function, actually the forward function, we can take 1 argument, 2 argument, and any number of argument, and we can return a number of output. It could be a single variable, could be single value, or it could be a tuple with multiple value. So we need to check the type of XS, YS. If it's a tuple, if it's not a tuple, we need to make it as a tuple with just single value. So the next is that we convert everything here as a variable. So this to be the output variable. Okay. Okay, so in this way, now we can implement the add operator. So after those call, we could write the program just just x plus 3 here instead of the like in this way. Okay, so you will make the code more intuitive, so that it will be easier for us to compare the code with the expression in the paper or in any document. Okay, so this is the discussion for the syntax sugar by using the operator override function of the Python language to make the code look more beautiful. But actually, those syntax sugar will not change the function at all. No, no matter you write the code in this way or in this way, it will be the same for in the runtime. The behavior will not have any difference. However, if you write the code in this way, for some more complex expression, which might be happen in your deep learning models or deep learning algorithms, it will look more intuitive and easier to be understood by others. Okay, and actually there's a lot of operators in the Python language. So in order to make people to write the code without the error, it's better we implement as much as possible. And if you look at the repository of the D0 framework, it has implemented all of them. So we can write the expression in Python language without any restriction. Okay, so that's all for the video today. In the next video, we will try to introduce some add functions. And if you still remember, in those functions, we have a backward here. Okay, and actually we do not discuss it yet. So in the next video, we will discuss how to implement the backward function for a couple of the functions, and we will explain how to make the mathematics to the implementation here. So stay tuned for the next video.